Hi students, today we will discuss the performance measurements. In this particular lecture, we try to understand how can we measure the performance of a computer. So what is the need to measure the performance? It is mandatory because whenever we want to compare the two different computers of two different configuration and of different make, we will have to compare the performance of these two. So now, how can we say one computer is faster than other? What are the different parameters on the basis of which we will say that this one computer X is faster than the another computer Y? Before we will discuss those different parameters which can be used to differentiate the performance of one computer from another, let us look at the performance measurements user's point of view and manager point of view. Well, let's suppose I am a user of a computer and I am using this computer to perform any task. For me, how much time that a particular computer will take to complete that task will be my interest. So my viewpoint will be the time taken to complete one task. But on the other hand, my boss, who is a manager, will be interested on number of tasks per unit time. So he will be more interested how many tasks I have completed in a given time. On the basis of this, the performance can be evaluated in terms of response time and throughput for these two viewpoints. For user's point of view, response time will be the parameter which will be used to evaluate the performance of a computer. So which means the response time, the definition of the response time will be how long it takes to do a task. So how much time a computer will take to complete a task. Let's suppose, for example, if a computer is taking 10 seconds and another is taking 15 seconds per task, for me as a user, a computer which is taking 10 seconds is more faster than the another computer which is taking the 15 seconds to complete the same task. On the other hand, throughput is a parameter which will be a parameter for manager's point of view, and if we will go and look at the definition of the throughput, it will be the total work done per unit time. So how many tasks, number of transactions completed in a per unit time, that is called the throughput. So how many tasks or transactions are completed in a given time, that will be the throughput, and it will be the parameter which will be manager's point of view. Now the another question is the response time, and now the question is how are response time and throughput affected. These are affected by replacing the processor, memory and IO devices with faster version. So which means how can we improve the response time? So naturally, if we will improve the response time, throughput will also be increased. So response time or throughput can be affected or improved or changed by replacing the processor, type of processor, processing speed of the processor, memory, type of the memory, and IO devices with the fast versions. Naturally, if we will replacing the processor, memory and IO devices with the fast versions, response time will reduce and throughput will increase. The another way is by adding the more processor. We can go with the multiprocessing. So what will be the role of the multiprocessing, or in case of multiprocessors, more number of tasks will be performed at the same time. So naturally, response time will decrease and throughput will increase. So now how can we find out the relative performance of a computer? So as we have already discussed in the previous slide, performance, what is the performance? Performance is nothing but throughput. So performance can be defined, it will be 1 upon execution time. So naturally, what is the execution time? It is the time taken by a computer to complete one task. And what is the performance? The performance is number of tasks handled per unit time. So that is why it is the performance or throughput is 1 upon execution time. Now let us compare the two computers, X and Y. Under what circumstances we will say that X is n time faster than Y? So what will be the mathematical equation which we can be used to evaluate the performance of X and Y? Let's suppose we are having two computers, X and Y, and we want to evaluate the performance of X and Y. Suppose or assume the performance of the X is n times faster than Y. Then how can we write the equation in terms of its performance and execution time? So if we will say that X is n times faster than Y, then we can write the program execution time in Y computer upon program execution time for X computer is equal to performance of X computer upon performance of Y computer is equal to n. So now if we will say that the X is n times faster than Y, then the meaning of this is the value of n will always be greater than 1. How? We will discuss this with example. Let's suppose the time taken to run a program 10 seconds on X and say 15 seconds on Y. So then what will be the execution time for X? The execution time for the X computer will be 10 seconds and execution time of Y will be the 15 seconds. As it is given in the above equation, the execution time Y upon execution time X. So execution time of Y computer is 15 seconds. Upon execution time of X it is 10 seconds. So value of n will be 1.5. So meaning of this is the computer X is 1.5 times faster than the computer Y, because the execution time of Y is 1.5 times more than the execution time of X. And similarly, the performance can also be evaluated in terms of performance or throughput. And as we have already discussed, that's the performance is equal to 1 upon execution time, and given is execution time. So 1 upon S, 1 upon 10 second will be equal to 0.1, and 1.15 will be equal to 0.0667. So if we will try to evaluate the performance in terms of throughput, it will be 0.1 upon 0.0667. That will also be equal to 1.5. So in both cases, the performance of X is 1.5 times better than the performance of Y. So we will say that the computer A is 1.5 times faster than the computer B in terms of performance and in terms of execution time. Now we will try to understand the performance measurements. So as in the previous example, we have considered that let's suppose the computer X is 1.5 times faster than the computer B. Similarly, we are going to assume that computer A is, if the computer A is n times faster than B, then we will write the program execution time in B upon program execution time in A is equal to n. That is, performance of A upon performance of B is equal to n. Now what is the execution time? The execution time is the time taken by the computer to complete one task. So this execution time can be defined either as elapsed time or CPU time. Now we will try to understand, we will try to differentiate what is the elapsed time and what is the CPU time. How can we differentiate these two terms, elapsed time and CPU time? The elapsed time is the latency to complete a task, which include the disk access, memory access, and I/O activities and operating system overhead, etc. Which means the elapsed time will be the time taken by a task, which includes not only the time taken by the processor to complete the task, but will also include the external memory accessing time, external input output devices accessing time, and the overheads required by the operating system to complete that particular task. So the total time taken by the computer to complete one task, including all the activities, is called the elapsed time. Here, what is the CPU time? CPU time will be called or known as the time taken by the processor to complete one task. It will not include any waiting time for I/O, any memory access time. It will not include any waiting period required for the slow I/O devices or slow memory devices. So it will be purely the time taken by the CPU to complete the task, which is also called the CPU computing time. It is called CPU computing time. So user will be more interested in the lapse time, not in the CPU time, because let's suppose I am the user. I will not be interested how much time a CPU is going to take and how much time it is going to waste to wait the IO devices, how much time it is going to consume to memory access. I will be interested as a user how much time a computer will take to execute one task. That will be my area of interest. So that is why I will be interested in elapsed time, not in the CPU time. So CPU time again for divided into two parts. One is called user CPU time, another is called system CPU time. What is the user CPU time? The user CPU time will be the time taken by the central processing unit to execute that particular task. That is the user CPU time. And what will be the system CPU time? The system CPU time will be the time which will be spent by the CPU in operating system performing tasks requested by the program. For example, let's suppose I have given one program to the computer. Computer will take say some time to execute that particular program. For me as a user, that will be the elapsed time. But if I will look at the detail of that particular lapse time, that particular lapse time will have CPU time, and CPU time further will be divided in two parts. One is called user CPU time, another is called system CPU time. User CPU time will be the purely a time taken by the processor to complete the task of the user. But during the completion of that particular task, if the need of the program to use or to request the operating system to perform some operation on the behalf of that particular program, that time taken by the computer will be known as the system CPU time. So I will explain it with the example. Let's suppose this is the command. This is a command of Unix which will be gives us the time. So now we will try to compare or we'll try to understand the lapse time, CPU time, system CPU time with the help of this particular example. This is a output of a command of Unix system. So the first term 90.7 is the user CPU time. So it is the time taken by the processor to complete the given task. So it will take the 90.7 second. So the second term is the 12.9 second, which is nothing but the system CPU time. So this particular time 12.9 second are taken by the CPU, in which the need of the as per the need of the program, CPU has assessed the operating system to complete the given program. And the third part is the 2 minutes and 39 seconds. This is the lapse time. Let's suppose I am a user. I will be interested in 2 minutes and 39 seconds, which is nothing but 159 seconds. For me, my computer has taken 2 minutes and 39 seconds to complete my task. Now, for a computer architect who is interested to look at the how much time is taken by the CPU, how much time is taken by the operating system, how much time was consumed by the input-output devices to respond or to provide the required data to the CPU. So until unless IO devices and memory will not provide the data to the CPU, CPU will have to be remained there in the waiting stage. So we will try to understand this. So 90.7 second is the user CPU time, 12.9 second is the operating system or system CPU time. The total CPU time will be the 90.7 plus 12.9. It will be 103.6 seconds. And for me, for user, this particular system has taken how much time? This particular system has taken 2 minutes and 39 seconds. So now if I will try to evaluate that uses of the CPU has used only 65% of the total elapsed time. The total elapsed time the total time taken by the computer to complete the task was 2 minutes and 39 seconds, out of which only 65% portion of 2 minutes and 39 seconds or 159 seconds. The CPU has taken only 103.6 seconds, so which is the 65% of the total time taken by the computer. So these are the some performance parameters which are used to evaluate the performance of a computer. So as we have already discussed in this particular slide, elapsed time, which is the total time taken by the computer, and this elapsed time will be the CPU time. CPU time will be the total time taken by the processor to complete the computing of the required program, excluding waiting for input output devices or memory. Okay, so now we will try to understand the execution time of the two different programs with three different machines or three different computers. So we will consider one example. Let's suppose we are having the three different computers with us: computer A, computer B, and computer C. And on each computer we will have to run two programs, program P1 and program P2. Let's suppose program P1 is taking 1 second on program computer 1, and a similar program was taking 10 seconds on computer B, and same program was taking 20 seconds on computer C. On other hand, for program 2, computer A is taking 1000 seconds for computer A, 100 seconds on computer B, and 20 seconds on computer C. So now these are the two different programs, and we have run these two programs on three different machines. So now how can we compare the performance of these three computers? On the basis of the given data for program 1 and program 2, what can we do? We can understand from the performance of these three machines with respect to these two programs, we can conclude computer A is 10 times faster than B for program 1. On the basis of the programs, if we will try to compare the performance on the basis of the programs, then we can say that computer A is 10 times faster than the computer B for program 1. Computer B is 10 times faster than the computer A for program P2. Computer A is 20 times faster than the computer C for program 1. And computer C is 50 times faster than computer A for program 2. On the other hand, computer B is 2 times faster than computer C for program 1, but computer C is 5 times faster than the computer B for program P2. From this summary of the performance of the two different programs for three different machines, it is not clear which computer is having better performance as compared to other. If we look at this, in one program, computer A is faster than B. For another program, computer B is faster than A. And again, in one program, computer B is faster than computer C. And another program, for program 2, computer C is faster than for computer B. So from this method, on the basis of the individual programs, we cannot compare the performance of the different programs. We cannot conclude we cannot evaluate the performance of the different computers. Then what we'll have to do? We can just take the total time. This is the one method. So what will we do? In the third row, the total time of the all the two programs is given. So for computer A, the total time is 1001 second. For computer B, it is 110. For computer C, it is 40 seconds. So from the total time, the performance of the computer C is the fastest, and the performance of the computer A is the slower one. Okay. One more method can be used to evaluate the performance. That is, we can take the average of the execution time of all the programs. This is another way. So an average of the execution time that track the total execution time is called the arithmetic mean. So we can also take the arithmetic mean. So to calculate the arithmetic mean, so this particular equation can be used in which it will be the average of the sum of, so arithmetic mean will be the sum of all the time. So arithmetic mean will be the sum of time taken by all the programs divided by number of programs. So if we will take the arithmetic mean of the computer A, so arithmetic mean of the computer A will be 500.5. For computer B it is 55, and computer C it is 20. So on the basis of arithmetic mean, still computer C is the fastest computer and computer A is the slowest computer among all these three. But still, in this particular performance evaluating methodology, still one thing is not clear. That is, what are the weights of the different programs. In this particular performance evaluating methodology, we are assuming that the weightage of P1, program 1 and program 2 is same. But what will happen if the weightage of the different programs will be different? Then this particular methodology cannot be used. This particular method cannot be used to evaluate the performance of the different programs for the different machines. So then what will we do for that particular, in that particular case? In that particular case, we will go with the weighted execution time. So what will be the weighted execution time? In this particular methodology, in this particular method, a weight will be allotted to each and every execution time of each and every program for every machine. So what is the proper mixture of the program for the workload? In this particular method, we must know, or we must try to understand what is the proper mixture of the program for the workload. Are the program P1 and P2 run equally in the workload? If yes, then weight will be 0.5 and 0.5 as it is given in the weight 1. So if we will go with weight W1, which is nothing but the weight 1, and in this particular case we have assigned the equal weight to the two different programs. So it means these two programs, under this assumption, these two programs P1 and P2, we are assuming that will run as equally in the workload. But what will happen if the unequal mixing of programs in the workload is to assign a weighing factor to the each program? So what will we do? We can allot the different weighing factor to the different programs. So in this particular example, we are going to allot the two different weighing factor to these two programs. In W1 it is equally divided. For W2, say we will assume that the weighing factor for program 1 is 0.909 and for program 2 it is say 0.091. So whenever we will have to allot the weighing factor to the different programs, then one thing we must keep in mind, the sum of all the weighing factor must be equal to 1. So sum must be equal to 1. So for the third weighing factor, say we will assume that the weighing factor for program 1 is 0.999 and say the weighing factor for program 2 is say 0.001. Now we will calculate the weighted arithmetic mean. So how can we calculate the weighted arithmetic mean? This is the equation which will be used to calculate the weighted arithmetic mean. It will be what? It will be the sum of all the programs with respect to, it will be the sum of product. It will be the sum of product, where the product will be the weight allotted to that particular program and execution time of that particular program for that particular machine. Okay, so this is the way how can we evaluate the weighted arithmetic mean. So if we will take this particular example, so what will be the arithmetic mean for weight 1, as in this particular case we have allotted the equal weight. So if we will go with this equation, weight into time, weight is 0.5, time for program 1 is 1, it will be 0.5, and weight for this is 0.5 and time is 1000, it will be 500, and sum of these two products will be equal to 500.5. Similarly, it will be 55. So again it will be sum of product for weight allotted to the program 1 into time of the execution time of the program 1. Similarly, weight allotted to the program 2 into time of the program 2. So it will be 55, and for machine 3 it will be 20. So now we will go for the second weighing factor, which is W2. In case of W2, we have allotted the weighing factor to program 1, it is 0.909, and weighing factor to the program 2, it is 0.091. So again, similarly, by using the same equation, we will try to calculate the arithmetic mean of weighing factor 2. So it will be what? It will be weight, which is 0.909 into 1 plus 0.091 into 1000. Okay, so it will be 91.91. Similarly, for second machine, again we will go with 10 into 0.909 plus 100 into 0.091. So it will give us 18.19 second, 18.19 second. And for third machine, it will be 20, and this 20 will be the sum of the product of 20 into 0.909 and 20 into 0.091. So it will give us the 20. So similarly, we will evaluate the arithmetic mean by assuming that these are the weighing factor for program 1 and program 2. So it will give us 10.09 and 20. So now what can we conclude from this? From this we can conclude that the weighing factor have its own importance. If we will go with the equal weight for two different programs, then we can conclude that the computer C or machine C is the fastest one and computer A is the slower one. But if we will go with the weighing factor assumed for weighing factor 2, then computer B is the fastest one and still A is the slower one. But if we will go with the weighing machine, but if we will go with the weighing factor 3, in this particular case, computer A will take only 2 seconds to execute it. The arithmetic mean is only 2, and arithmetic mean for computer B is 10.09, and arithmetic mean for computer C is 20. So in this third arithmetic mean, the computer A is the fastest one and computer C is the slowest one. Now, so which means on the basis of weighted execution time on the basis of weighted arithmetic mean, the weight allotted to each program will also contribute towards the evaluation of the performance. So again, in the previous example, there was a different weights were allowed to the, as in this particular example, 3 different weights are allotted to the 3 different in this particular example 3 different weights are assumed, and accordingly 3 different arithmetic means were there. Accordingly, a set of 3 different arithmetic means were there, and from the outcome of those 3 arithmetic means, we were not able to define that which machine is fastest and which machine is the slower one. So the second approach which is used to evaluate the performance of more than one machines is called normalized execution time with the help of geometric mean rather than arithmetic means. So this is the second approach which is also used by the SPEC. SPEC is a what? It is a Standard Performance Evaluation Corporation. It is a corporation which are presenting the different benchmarks and different benchmark suits which are used to evaluate the performance by the different manufacturer to evaluate the performance of their computer. So it is a standard set. So the performance of the programs can be predicted by simply multiplying the normalized execution time. So before we will go and calculate the normalized execution time, we must know what is the normalized execution time. The normalized execution time will be the time in which the execution time of a unknown computer will be normalized or will be divided by the execution time of a known computer. So what is the normalized execution time? The normalized execution time will be the ratio of the execution time of unknown computer to the execution time of a reference computer. So the performance of the programs can be predicted simply by multiplying the normalized execution time. So first of all, we will evaluate the normalized execution time by calculating the normalized execution time of any unknown computer with reference to the execution time of same program on the another computer whose performance is already evaluated and well known. Okay, or standard computer or reference computer. So the average normalized execution time can be expressed as either an arithmetic or geometric mean, and the equation which can be used to calculate the geometric mean is geometric mean will be equal to the, it will be the product of sum. It will be the product of execution time. Okay. So the geometric mean, the formula for the geometric mean can be calculated by using this particular equation. So this particular equation can be used to calculate the geometric mean of this particular equation can be used to calculate the geometric mean. Okay, so now by again we will consider the similar example which we have considered for the previous two cases. Say we are having three different machines A, B and C, and two different programs, program 1 and program 2, and these are the execution times for program 1 for different machines, and these are the execution time for the program 2 for the three different machines. So first of all, we'll have to calculate the normalized execution time. As we have already discussed that what is the normalized execution time, out of these three we will have to consider one as a reference computer, and we will assume that the performance of that particular computer is well known. So we will consider that particular performance is well known to us, and we will consider that the performance of that computer as a reference. So for this particular, so first of all we will normalize the performance of B and C computer with respect to the computer A. So to do so, what will we do? We will divide the performance of A with performance of A, because we are considering the computer A as a reference computer. So it will be 1 upon 1 is equal to 1. And to calculate the normalized execution time for B, to calculate the normalized execution time of computer B for program A, what will we do? We will divide the execution time of computer B. We will find the ratio of execution time of computer B to the execution time of computer A. So it will be 10 by 1 is equal to 10. Similarly for computer C, it will be 20 by 1 20. So now we will calculate the normalized execution time for computer B and computer C with respect to the computer A. So to evaluate the normalized execution time for computer B for program 2, it will be 100 by 1000. So 100 by 1000 will be equal to 0.1. Similarly, 20 by 1000 will be equal to 0.02. So these are the normalized execution time of the computer A, B and C, and this normalization is done with respect to the computer A. Similarly, then for the next we will do normalization of all the computers with respect to the computer B. So for program 1 of computer A, it will be what? 1 upon 10 will be 0.1. For computer B, it will be 10 upon 10, 1. For computer C, it will be 20 upon 10, it is 2. Similarly, for computer A, it will be 1000 upon 100, it will be 10. 100 upon 100, 1. Then it will be 20 upon 100, 0.2. Similarly, for this, we will evaluate the normalization time, normalized execution time with respect to C by considering C as a reference computer. So it will be 0.05 for A and 0.5 for and 0.5 for B. Similarly, for program 2, it will be 50 and 5, and for program C, it will be 1. Now we will try to calculate the arithmetic mean by using the previous equation, which will be the average, nothing but average. Arithmetic mean, we will get the arithmetic mean, it will remain same. It will be now it will be 10 plus 1 upon 2, it will be 505. Similarly, 20 plus 0.02, it will be 10 plus 10.01. So 10 for this, and this particular row will be the arithmetic means of the all the normalized execution time. Now we will calculate the what? Geometric mean. And for geometric mean, it will be what? Product of execution time ratio upon 1 upon n. So how can we calculate this? This can be calculated by doing so. 10 into 0.1 is equal to 1. 10 into 0.1 under root 2, because the value of n is equal to 2. Here we are executing we are using this example for 2 programs. So it will be 10 into 0.1 under root. Similarly, this will be 20 into 0.02, whatsoever the product will be of this 2 terms product, and we will have to take 1 by 2 as 2 programs are there. So it will be 0.63. Similarly, we will evaluate the performance for normalized execution time with respect to B and with respect to C. So these will be the normalized geometric means for different sets of normalized to A, normalized to B and normalized to C. So the last row will gives us what? It will be the total time. So from this total time, what can we conclude? We can conclude that the total time taken by with respect to A is 1, for B it is 0.11, for C it is 0.04. So if we look at this, then the computer C is the fastest computer. Computer C is the fastest computer, and it is computer B is almost 2.5 times slower than the computer C, or computer C is 2.5 times faster than the computer B, and A is the slowest computer. Okay. Similarly, if we will go to the normalized execution times for C, and then we'll find that if we will consider that the computer C is taking 1 second to execute the program, then B will take how much? 2.75. So it means computer B is 2.5 times slower than the computer C, and computer A is 25 times lower than the computer A. If we will try to evaluate this, then we will find that the same relation is there for the, we will get the, if we will try to conclude the one thing, that is the ratio of the speed of all the three computer is same. It is 1, 2.75, 25.03. The similar ratio is there for A, B and C with these values, and similar ratio will be there for the A, B and C for these values as well. So it means whenever we will have to find the performance by using the normalized execution time, in which we will find the geometric means by using the normalized execution time, in which we will evaluate the performance of one unknown computer with reference to the a knowing computer. Then we can evaluate the performance with this method. So this is the method which is used to evaluate the performance of more than one computers. This is used. So this is the method which is used to compare the performance of more than one computer, in which we can consider one computer as a reference computer, and the performance of other computers can be evaluated on the basis of known reference computer by using normalized execution time and geometric mean. This particular methodology is also used in the SPEC. What is SPEC? SPEC is a standard performance evaluation corporation, which are offering the benchmark suits, and those suits are used to evaluate the performance of newly built computer. Different companies are using those benchmark suits to evaluate the performance. So this is all about how can you evaluate the performance. In the next lecture, we will discuss the what are the SPEC benchmarks, and how the SPEC benchmarks are used to evaluate the performance of different computers. We will try to understand the SPEC benchmarks with the help of different examples. Thank you.